Okay, so we're going to do a quick review of stoichiometry. Hopefully it comes back to you pretty quick. Technical definition of stoichiometry is the calculation of reactants and products in chemical reactions, as according to Wikipedia. It is a process, it's a method, it's a way of calculating the amount of product or reactant from a given amount of product or reactant, and it all has to do with the fact that things react in terms of something called the mole. So, if we look at a really small level, we could say that reactions always take place in terms of atoms or molecules or formula units when the old bonds are broken and the new ones form. But you can't calculate that. You certainly can't count them. But moles are proportional atoms. We can use moles to do stoichiometry. So this is a balanced equation. All the hydrogen out there in the world comes diatomic. All the oxygen comes out diatomic. When they react, though, they react and form water where there's two H's and only one O. Well, the law of conservation of matter says you cannot create or destroy atoms. That means if I have two atoms of O, because that's the way it's created, I have to have two atoms of O over there. The way we accommodate that is, so we have coefficients that represent the different ways of balancing equations. Okay, so that's a balanced equation. So it indicates that it takes two molecules of the water, or the hydrogen, to react with one molecule of oxygen to form two molecules of water, because matter cannot be created or destroyed. So if we could look at it and actually count, that's how they react, in a 2 to 1 to 2 ratio. But if we look at it on a larger scale, where we're talking molecules, it takes 1.204 e to the 23rd molecules of hydrogen to react with 6.02 e to the 23rd molecules of oxygen. It forms 12.04 e to the 23rd molecules of water. So it's still that same ratio, 2 to 1 to 2. It's just a much larger scale. Okay? Those two numbers, three numbers, represent moles. It's 2 moles is that, 1 mole is that, and 2 moles is that. And so moles are proportional to the numbers of atoms, and that's why it works, because everything reacts in terms of atoms or molecules. It's real obvious when you see it in terms of molecules or in moles, but when they involve grams, it gets a little more complicated. You can't do that. So here's the same reaction. 2 to 1 to 2, 2 to 1 to 2, 2 to 1 to 2. And then when we get to mass, everything's off. But the important thing you should notice is that mass cannot be created or destroyed. If I have 2 moles of hydrogen, it weighs 4 grams. If I have 1 mole of oxygen, it weighs 32 grams. And 2 moles of water weighs 36. So mass is not created or destroyed, but it's not the same ratio because things are not the same mass. So to do stoichiometry, you must convert the amount you start with to moles. Or if you feel like going all the way to molecules, you can do that too. But you have to definitely do moles. So first thing you need is balance the chemical equation. Then you're going to convert whatever you start with to moles of the first chemical. You're going to use the mole ratio from the balanced equation to convert to moles. This right here is stoichiometry. That's the only part of it that's stoichiometry. This is a conversion. The next step is just a conversion. It's the one in the middle that makes it the stoichiometry. So when it comes to doing this, anytime you're given both reactants, it is considered to be a limiting reactant problem. One of the reactants is most likely going to run out before the other one. It limits the amount of product you can get, so we call it the limiting reactant. The other one will have extra left over after the limiting reactant runs out, and it's referred to as excess reactant. So I'm just going to run through a problem real quick on it. The easiest way to do this, though, I think, is to do a stoichiometry setup for each reactant and turn it into the same unit of the same product, and then just pick the smaller number. Whichever one produces the least amount is the one that limits it, and that's the one you're going to use. So if I have 75 grams of nitrogen reacts with 15 grams of hydrogen, and you want to identify which reactant is limiting, well, you take it, I'm going to write it over here, I'm going to just change it into moles of NH3 in this case, because that's my product. So I have 75 grams of nitrogen. I do a conversion to change it into moles. And then I do the balanced equation, which is the stoichiometry. It takes 1 nitrogen to produce 2 NH3s. That is 5.3 moles of NH3. 3.6 if you want to be real technical. All right, then I do the 15 grams of hydrogen. Change it, convert it to moles. It takes 3 hydrogens to make 2 ammonias, and that is 5. I think almost exactly, yeah, 5 moles of ammonia. So the hydrogen is my limiting reactant, and it can produce a maximum of 5 moles of NH3, assuming 100% goes to products. Okay, so this one is my excess reactant. Now, what mass of NH3 can be made? Well, all I have to do is take that 5 moles and I need to convert it from 1 mole into 17 grams for NH3, which is 85 grams. Now, here's the question that makes it tough. What mass of excess reactant remains behind? Anytime you're trying to find the excess reactant, there's a lot of different ways of solving this, but you must subtract somewhere. Because some of your reactant gets used and some of it doesn't. That requires some kind of a subtraction. So what I'm going to do is I'm going to look back at what I already have for my numbers. I had 5.36 moles NH3, and that was from the nitrogen. And the hydrogen allowed me only to make 5 moles of NH3. So the hydrogen was my limiting reactant. It only allowed me to make 5 moles of NH3. That means if I subtract those two numbers, what I get is 0.36 moles of NH3 that would have come from my excess nitrogen. It could make an additional 0.36 moles of NH3. So I did my subtraction, but then I have to convert it back to the reactant. And again, it depends on what you subtract, but I just subtract the last numbers I had. I have 2 NH3, and they come from 1 nitrogen, and 1 mole of nitrogen is 28 grams. And so when I do that subtraction, I end up with 5 grams left over. And I want to point out, I started with 75 grams of nitrogen and 15 grams of hydrogen. That is a total of 90 grams of reactants, and I have 5 grams of nitrogen left. That's a 2. And I had 85 grams of NH3 made. And look at that, mass is not created or destroyed. This is how much product I got, and this is how much nitrogen I had left over. And so it's a really good way of identifying how much excess stuff there is. But the biggest thing is you have to remember to subtract somewhere. And it just depends on what you have. There's no one right way or wrong way.